All right, guys, today we're doing lesson 2.1b. Just looking at the quadratic like parent function, which is just y equals x squared. And you guys can go to Desmos, right? I have Desmos up, I think. It's a recording. Desmos right here. Just go to desmos.com and then, you should get a calculator that pops up. After you like start exploring or something like that. All right, so we're going to look at the parent function, which is just y equals x squared, right? Now, before we go to Desmos, we can probably just graph this on our own, right? Um, it's y equals x squared. So if we want to create like a table of values, I would say like these are our staples for x values. We usually go from -2 to +2. And when I think about plugging in these x values into this equation, right? If I plug in -2 squared, well, -2 squared, right? You plug it in like with parentheses, is going to give me +4, right? So -2, 4 is a point on my quadratic parent function, which is just y equals x squared. -1, when I plug it in, I get +1. 0 is 0, right? When I plug in 1, 1 squared is 1, and 2 squared is 4, right? So these are all that I need. You could get 3, 9, 4, 16, right? Those are all possibilities too. But just for what I'm doing right now, I'm just going to connect these. Just always make sure to use arrows because this parabola is going to go up and up and up forever. So that's it, right? And if I wanted to do on Desmos, y equals x squared, so x times x, and that's what it looks like, right? 0, 0, 1, -1, 1, -2, 4. It's all the same stuff. Now, the first one I want to look at, just moving the parent function around a little bit or doing things to it, would just be -x squared, right? So what if I did y equals -x squared? Well, it's really the same thing as x squared, right? All of these y values are going to stay the same, but then I'm going to stick a negative sign in front of it, right? So instead of -2, +4, it would end up being -2, -4, right? And then instead of -1, +1, be -1 squared. You'd have to do that first just with PEMDAS, and then you'd stick the negative sign out. So I get -1. 0 would stay at 0. 1 would still give me -1. 2 would give me -4. And what you'll see is it's actually going to be a reflection over the x-axis, right? It's the same thing as the parent function. It's just reflected over the x-axis, which is basically what this negative sign is doing. Different transformation, right? So let's say we still have y equals x squared, and we can actually, let me just show the last one. -x squared, right? So that's just showing us what we had. The next one is y equals 3x squared. So it's kind of like this, it's purple compared to our original parent function, which is the blue one. And you can see this is what we call a vertical stretch. It is the blue one, but everything's being stretched up by a factor of 3. What do I mean by that? Well, instead of the point 1, 1, we actually have the point 1, 3, right? Instead of our point 2, 4, we actually have 2, 12. So all of those y coordinates, because of this 3, are being multiplied by 3, right? Now 0 times 3 is still 0, but every other y coordinate is going to be multiplied by 3, which results in what we call a vertical stretch, right? So, what if we did 0.5x squared, right? Because we had something like narrow wide or vertically stretched and vertically compressed. Well, if we did 0.5, this is the black one. So again, we're comparing it to the blue one. I could delete off this one, and I'll delete off the reflection too, right? So compared to the blue one, this is what we call vertically compressed or shrunk. So again, instead of our net point -2, 4, we actually have -2, 2. So we take that 4 and we cut it in half. Instead of -1, 1, we have -1, 1/2. So this 0.5 is same thing as the original, but you're taking all of those values that we plotted in for the first one, and you're going to cut them all in half. Right, so that's why the 0.5 is what we call a vertical shrink. You can see it there. So all of your table of values, instead of -2, 4, you'd have -2, 2. All of these y values would be cut in half because of the 1/2. Throw a couple other ones at it. What if we did a negative and a 1/3, right? So -1/3 x squared. So we'll go y equals -1. Whoops. -1/3 and then x squared. So the negative right? Remember we talked about the other day, if it's a negative sign, that's going to mean it opens down. So that's responsible for the reflection of the parent function, which is why it opens down, right? The a value is negative. And then the 1/3 has basically caused this graph to be, again, vertically compressed or shrunk, right? It's wider, which is just kind of a way of saying vertically compressed or shrunk. So you kind of get two of them there. Now, if I take this, the last one I want to show you, what if we did x squared, and then we did like a +3 at the end, right? All right, let me give you the negative one again. So it's this darker blue one, which they gave you a different color. So again, comparing it to, let's compare it to the red one. It's actually the same thing as the red one, but this +3 simply moved it up 3 points, right? So this point right here, which was -2, -3, or -3, -3, is actually 0, -3. 0, 0 is now 0, 3. All of the points have been shifted up 3 units, which kind of results from that +3, the +3, right? But it's still vertically compressed because of the 1/3, and it's still reflected because of the negative sign. And I'll give you one more example in the second video.